Now, we have we have seen how the three registers, the data direction register, the DDR, the port input register, and the port register help us to do input output from a particular um, from a particular uh, pin, right? Now, there are some complications here which I think we need to consider right now. One of the things is that any register in Atmega 328 is not 1 bit in length. It is 8 bits. Okay, that's just the way the microcontroller is built. The Atmega 328 is a 8-bit microcontroller, which means that all registers in it are 8 bits, which means that, let's say, if DDR is a register, it will have it will have 8 bits associated with it. When I say DDR 0 to 7, what I mean is there are 8 paths or 8 bits in that particular memory location, right? So I can draw it like this. So 0, 1, 2, 3, 4, 5, 6, and 7. So that those are the bits of this register. And uh, the data, so this register has these 8 bits. Now when we were talking about controlling one particular pin, we only need 1 bit to control it, right? So we only need 1 bit because you only want to set it to 0 or 1. So we are wasting a lot of space. So what people have done is they have taken the microcontroller pins. So you have this different pins on a microcontroller. As I said before, there are 28 pins on Atmega 328. And what you do is you take 8 of these pins and you group them together and call them an input output port. Okay, so let's call it input output port A, or you could call it port B or port C, as you would like. Okay, and now what we say is we allocate this register data direction, which has 8 bits to it, with each bit corresponding to one of these pins. Okay, so the 0th bit of DDR, and let's call it DDR A to associate it with port A. So the 0th bit of DDR-A controls whether the 0 pin in port A is input or output. Similarly, the second, or DDR-A2, so which is this bit, controls which pin? It controls 0, 1, 2, the second pin, this pin, whether this pin is an input or an output. Okay, similarly, if you set, let's say, pin 3 here as an input, okay, so which pin is going to be, so you are setting, sorry, you're setting this register here as a, let's say, a 0, which is a setting for making a input output pin an input. So which pin is going to become an input? The third pin, this pin. So this becomes an input. So when it becomes an input, where does the data that is coming in get stored? It gets stored in pin A, which again has 8 bits, and the data from pin 3 gets stored in pin A3. Does that make sense? Now let's say you set pin 6 as an output. Okay, so you put a value of 1 in at this place in DDR6. So which pin has been set as an output? It is this pin. This is pin 6, and this pin 6 of port A, input output port A, has been set as an output. So where is the data that is going to be sent through pin 6? The data is at port A which is again an 8-bit register, and it is going to be in the 6th place in port A. So port A6 will have the data that is going to be sent out of pin 6. So what we have done is we have grouped the microcontroller into different ports, and so that we don't have 1-bit registers, but you have 8-bit registers, and each register can control 8 pins at the same time. Of course, individual bits in that register control individual pins, just like we discussed in the previous lecture.